Jason's salary and Karen's salary were each P% greater in 1998 than in 1995. What is the value of P? So we want to be able to make translations that involve equations involving P. And so can we do that? So what do we know? So we got two salaries. We got Jason's and we got Karen's, and we have those salaries at 2 points in time. So we got 1995, then we got 1998. So if we start, and so this is just from looking at the prompt by saying, okay, we'll say in 1995, Jason had a salary of J and Karen had a salary of K. So what does that mean their salaries were in 1998? So we have a P% increase. And so this is where knowing how to translate percent increases come in handy, because that means in 1998, Jason had a salary of J times 1 plus P over 100. And Karen had a salary of K times 1 plus P over 100. And so based on these expressions, we want to be able to make equations now where we can solve for P. And so let's see if we can do that from our statement. Statement 1 says in 1995, Karen's salary was $2,000 greater than Jason's. And so here we know K, so that's Karen's salary in 1995, is equal to J, Jason's in 1995, plus $2,000. Can't solve for P here. We don't even have P in our equation. So certainly insufficient. Statement 2 says in 1998, Karen's salary was $2,440 greater than Jason. So in 1998, now we do have our P. So we got to think a little bit more here. So in 1998, Karen's salary is K times 1 plus P over 100. That is equal to Jason's salary in 1998, which is J times 1 plus P over 100, plus 2,440. Now, by itself, this will still be insufficient because we have one equation here and 3 variables. And so it looks like if we're going to be able to solve for P, it will have to be together. And so here we know K is equal to J plus 2,000, and we can plug that in here. And so now we know J plus 2,000, that's K. So this times 1 plus P over 100 is equal to J times 1 plus P over 100 plus 2,440. Now, here you might say we still have one equation and 2 variables, and so it will be insufficient. But I'm thinking that this J might cancel out. And so let's see if that actually is the case. If I distribute my equations here, I have what, J plus a JP over 100 plus 2,000 plus 2,000 P over 100, which is just 20P, is equal to J plus a JP over 100 plus 2,440. So what happens to our J's here? So these J's cancel out. These J's cancel out, and we're left with just 2,000 plus 20P is equal to 2,440. And so that leaves us with 20P is equal to 440. And here it looks like we can get our P. P is equal to, so what, 22 times 20 is 440, right? Because 44 with 1 0, so P is just equal to 22. Or you can say their salaries increased by 22%. Together, they end up being sufficient. C.